In this video, you're going to learn how to name type 1 compounds, and we're going to concentrate on those that have polyatomic ions in them. The first thing you have to know is what a type 1 compound refers to. Type 1 ionic compounds are those kind, especially when they're type 1, that have metals or polyatomic ions with known charges. So typically when we're talking about type 1 ionic compounds or type 1 metals, the metals that we're talking about are any metals that are in those two groups, because those always have the same charges: aluminum, zinc, cadmium, and silver. The polyatomic ion that we're talking about in type 1 compounds is ammonium, which has a charge that doesn't change, is always +1. So besides groups 1 and 2 and aluminum, which is in group 3, the other metals that we need to watch out for are silver, which always has a +1 charge, cadmium, which always has a +2 charge, and zinc, which also always has a +2 charge. And by the way, aluminum is the only metal that we're concerned about in group 3 as far as type 1 compounds go. And the charge on aluminum is always +3. As soon as you identify a compound as a type 1 compound, what you need to do when you're naming it is split the name in half. So for example, if we have sodium sulfate, when we look at the first metal here, sodium, and realize that it's a type 1 metal, we're going to split the compound in half with a squiggly line and write out what the ions for both sides look like. So sodium, the ion looks like Na with a +1 charge. For sulfate, that's SO4 with a -2 charge. And just like with our binary compounds, at this point, we're going to circle the number, not the plus or the minus sign, just the number, and then we would cross those over to the other ions. So this is going to be Na2SO4. And again, because the 1 is the thing that came down, we don't write 1s down as subscripts. But one thing that you do need to watch out for is parentheses. You will sometimes need to use parentheses. You're only going to use parentheses when you have more than one polyatomic ion. In our case, we had only one of this polyatomic ion here, so we didn't need to use parentheses. Had we had 2 or 3 that we were going to be bringing down here, we'd want to use parentheses. And the reason for those parentheses is so that we can separate out the numbers that are down below. Let's look quickly at an example where we need to use parentheses. Something like calcium nitrate. We could easily identify calcium as being a type 1 metal, and once we do that, remember, we're going to draw the squiggly line, and below each of these things we're going to write down the ion. The calcium ion looks like this, the nitrate ion looks like this. And then we're going to circle the numbers, not the charges, just the numbers, and bring those down. It looks like we're going to end up with 1 calcium, but you can see here, because this 2 is coming down here, that's going to be 2 nitrates. And because we have 2 of a polyatomic ion, we need to put nitrate in parentheses, with the 2 on the outside of the parentheses. Notice if you didn't have the parentheses in, this would look almost like 32 oxygens in calcium nitrate, which looks really, really weird. So the reason, again, that we are putting parentheses is to make sure that we're giving a separation between this subscript number and this subscript number. Okay, the next example on your sheet, I think, is sodium sulfate. So sodium is a type 1 metal, so this is going to be a type 1 compound that contains a polyatomic ion. So again, squiggly line, and sodium looks like this. Sulfate is SO4 negative 2. And now we're going to circle these numbers, not the charges, just the numbers. And then we're going to bring them down. So sodium sulfate is Na2SO4. Remember, because it was a 1 that was going down here, we're not going to actually write the 1 anywhere. The second example I think I have on your sheet there is ammonium phosphate. Okay, remember that ammonium is the only polyatomic ion that's considered a type 1 polyatomic ion. So we're going to put the parentheses here and then write the ions with the charges below. So remember, ammonium looks like this with a charge of +1. Phosphate is PO4 with a -3 charge. Then we're going to circle the numbers, not the signs, just the numbers. And then we're going to bring them down like this. And because we're going to end up having 3 ammoniums, we're going to need parentheses around that. But because it's only one of the phosphate, we don't need parentheses around the phosphate. In fact, it's wrong if we put parentheses around the phosphate. So our final answer is going to look like this. And again, the reason that we used these parentheses here was to separate out that 4 subscript from the 3 subscript. Okay, the next example is calcium sulfate. Calcium is a type 1 metal, so we're going to split this up with a squiggly line and go ahead and draw the ions for both sides. Calcium looks like this. Sulfate is SO4 with a -2 charge, and then circling our numbers here, not the charges, just the numbers. In this case, I want you to notice that the 2 is the same. So just like we did for binary compounds, we're just going to shove these things together. We're not going to actually cross the numbers over. So our final answer is just CaSO4 with no parentheses or anything else because we just shoved them together. When we're actually naming compounds that have polyatomic ions in them, we kind of name it the same way that we do other type 1 compounds. We name the metal, the full metal's name, and then we name the polyatomic ion with the polyatomic ion's full name. So in this case, there isn't an "ide" like there is in binary compounds. The next example on your page is NH4 parentheses 2SO4. This is a type 1 compound because of the ammonium. Ammonium is always going to act like a type 1 compound. So as far as naming goes, we're going to name this ammonium because that's the name of the first part, or the cation, and the name of the second part is just sulfate. So the name of this guy is ammonium sulfate. And notice there isn't an "ide" on it this time because that polyatomic ion does not have an "ide" on it. If the polyatomic ion was something like OH, which has an "ide," it's okay to put the "ide" on there because remember, OH is hydroxide. But we just want to name the polyatomic ion whatever the actual name of the polyatomic ion is. In our case, this time it was sulfate. And the first polyatomic ion, remember, was ammonium. The next example I have there for you is AgNO3. We know this is a type 1 compound because silver is one of those type 1 metals. So the name for this compound is just going to be silver, which is the name of the metal, and then the name of the polyatomic ion or nonmetal. In this case, it's nitrate. So AgNO3 is silver nitrate. The next practice problem is asking you for the formula of zinc chloride. So zinc chloride, we know that zinc is one of those transition metals that actually acts like a type 1 compound. And because it's a type 1 compound, we're drawing our squiggly line, and then our ions below it. Keep in mind that zinc has a +2 charge. And then chloride is Cl with a -1 charge. So we're circling the 2, circling the 1, which means we're going to end up having 2 chlorides and just one of the zinc. So that's going to be ZnCl2 for zinc chloride. The next example on your page there is ammonium oxide. So we know that ammonium is a polyatomic ion that acts like a type 1 compound. So again, we're going to split this guy up and write out the ions. So ammonium is NH4 with a +1 charge. Oxide we know is O with a -2 charge. We're going to circle those numbers, not the plus or minus sign, just the numbers. And then we're going to bring them down as subscripts diagonally. So it looks like we have 2 ammoniums. And because we have 2 ammoniums, we need to put the ammonium in parentheses so that we don't get confused with this 4 and that 2. And then we have only 1 oxygen, so we're just going to put the O there. Remember, we don't bring those 1s down. So right here is a formula for ammonium oxide. Couple more practice problems left, it looks like. That third practice problem is ammonium chloride. So ammonium chloride, ammonium being a type 1 polyatomic ion, we're going to do this. Ammonium looks like this. Chloride looks like this. Circling these numbers without circling the charges. In our case, this time they're the same number, 1 and 1. So that means that we're just going to shove these two together. So ammonium chloride is NH4Cl. Alright, looks like the last one on your sheet there is aluminum phosphate. And aluminum is in group 3 and is a type 1 metal, so we're going to put our squiggly line. Aluminum has a +3 charge, like I said. And then phosphate is a polyatomic ion. That's PO4 with a -3 charge. So circling that number and that number again, these are the same. So we're actually just going to shove these two together. So aluminum phosphate is AlPO4 with no parentheses and no other subscripts to be added.